Glycogenin. Glycogenin is an enzyme involved in converting glucose to glycogen. It acts as a primer by polymerizing the first few glucose molecules, after which other enzymes take over. It is a homodimer of 37 kDa subunits and is classified as a glycosyltransferase. It catalyzes the chemical reactions UDP-alpha-D-glucose plus glycogenin equals UDP plus alpha-D-glucosylglycogenin. UDP-alpha-D-glucose plus a glucosyl-glycogenin equals 14 alpha-D-glucosyl-glycogenin plus UDP plus H+Thus. The two substrates of this enzyme are UDP alpha-D-glucose and glycogenin, whereas its two products are UDP and alpha-D-glucosylglycogenin. Nomenclature. This enzyme belongs to the family of glycosyltransferases, specifically the hexacyltransferases. The systematic name of this enzyme class is UDP alpha-D-glucose, glycogenin alpha-D-glucosyltransferase. Other names in common use include glycogenin, priming glucosyltransferase, and UDP glucose, glycogenin glucosyltransferase. One may also notice that the naming of glycogenin hints at its function, with the glyco prefix referring to a carbohydrate and the genin suffix derived from the Latin genesis meaning novel, source or beginning. This hints at the role of glycogenin to simply start glycogen synthesis before glycogen synthase takes over. Discovery. Glycogenin was discovered in 1984 by Dr. William J. Whelan, a Fellow of the Royal Society of London and current Professor of Biochemistry at the University of Miami. Function. The main enzyme involved in glycogen polymerization, glycogen synthase in the liver, and in the muscle glycogen synthesis is initiated by UDP glucose, can only add to an existing chain of at least 3 glucose residues. Glycogenin acts as the primer, to which further glucose monomers may be added. It achieves this by catalyzing the addition of glucose to itself autocatalysis by first binding glucose from UDP glucose to the hydroxyl group of T-194. 7 more glucoses can be added, each derived from UDP glucose, by glycogenin's glucosyltransferase activity. Once sufficient residues have been added, glycogen synthase takes over, extending the chain. Glycogenin remains covalently attached to the reducing end of the glycogen molecule. Evidence accumulates that a priming protein may be a fundamental property of polysaccharide synthesis in general. The molecular details of mammalian glycogen biogenesis may serve as a useful model for other systems. Structure. Isozymes. In humans, there are 2 isoforms of glycogenin, glycogenin-1, encoded by GY-GON and expressed in muscle, and glycogenin-2, encoded by GY-G2, and expressed in the liver and cardiac muscle, but not skeletal muscle. Patients have been found with defective GY-GON, resulting in muscle cells with the inability to store glycogen, and consequential weakness and heart disease.